So, how fast must a 1,000 kilogram car be moving to have a kinetic energy of 2 times, that's about 1,000 joules, and 2 times 10 to the 5th joules, and 1 kilowatt an hour. So this is a multi-step thing. Yeah, so let's start off by giving the givens, which is this. So we can draw, actually let's just draw the car. Just draw muscle mass car, I don't know. And it's going that way. So the givens are 1,000 kilograms. The mass of the car equals 1,000. Then what else? We have givens. And then we have what do you call it? We have lots of velocities. No. We have lots of kinetic energies. So KE, let's just call this KEA equals, I'll just do one of them, 2 times 10 to the 3rd joules, which also equals 2,000 joules. Well, they're essentially the same, just like more zeros. Okay. 10 to the 3rd is 1,000 times 2 is 2,000. It's 2,000 joules. Right. Yeah. So we have to get out our Nash equation, which is kinetic energy equals 1/2 mass times velocity squared, and what we're actually looking for is speed. Or the speed. What is speed? Which I'll write here, V of A, which is related to the kinetic energy of A. This is right here, what we're focusing on. Oh, let's italicize that. V of A equals question mark, and that's what we're trying to find out. So, what we want to do is we want to isolate the speed of A. This is good. So we want to get this guy alone. Right, by doing that is we have to move all of this over here to get the speed alone. So V, we're going to have to divide by 1/2 the mass and put it to the kinetic energy, which I'll just keep it there. I'll just keep it as variables. So it's kinetic energy divided by 1/2, which is also known as 0.5 of mass, which is still equal, just bring this guy down, is velocity squared. And how do we get rid of square roots? We just square both sides. How to get rid of squares? We have to square root both sides. Velocity equals square root of kinetic energy divided by 0.5 of the mass. Alright, so now we isolated the velocity of what we wanted. So we have we're getting to this step. So now all we gotta do is just plug in. So 2,000 joules right here, plug in to kinetic energy. The mass right here of 1,000 kilograms, you plug in right there. So yeah, I'm going to get a new paint. Just like resize it. Oops. So yeah, we're still looking at part A, and we're still looking for the speed of part A. Alright. Damn, this is getting a little choppy. So I'm gonna just rewrite everything right now. So we have the givens of mass equals 1000 kilograms. The kinetic energy equals 2000 joules. Okay, so yeah, let's keep it like that. And we also have this equation from the last equations I did, which is speed of example A should be equal to the kinetic energy divided by 0.5 m. So we just plug it in, Ke to the top, the kinetic energy to the top, which is equal to square root of 2000 joules divided by 0.5 times 1000 kilograms. Oh, that's so hard. So, yeah. So joules. Let's just cancel out numbers right now. So 2000 divided by 1000 is 2. So it's going to be just 2 on top with the joules on top still, and then 0.5 on the bottom, then kg. Kg still here. 0.5. When you divide by 0.5, it also multiplies by 2, because you divide by 1 by 0.5. Let's just put an example. 0.5 is also 1/2, right? As we said right. We said right here, over here, on the right. So I just converted it. 1 divided by 1/2. Alright, this gets into mixed fractions. So what's 1? 1 is also known as 1 over 1. Then you have to divide that 1 over 1 to 1, right? So I'm just setting the top one numerator as a fraction. Then the 1/2 stays 1/2. And what you do is you have to flip the bottom upside down. Well, sort of. Let's go this way. Upside down. So it's going to be 1 over 1. And this part you have to multiply. So it's going to be 2 over 1, which also equals 2. 1 times 2 is 2. 2 divided by 1 is 2. Okay? So what we're doing right here, dividing by 0.5 is actually multiplying it by 2. So it's going to be 4 joules over kilograms. I think I should be okay. Yeah. So if we look over here, I have equation sheet, but it's sort of a cheat sheet. So joules is also equal to kilograms meters squared over second squared. So if we had kilograms being divided by joules, that's a horrible example. Damn it. Let me get a new one. Paint. Ran out of space so fast. It's crazy. I get used to it. So right here, we'll just bring this over. Joules. I'm just doing the unit conversions, but this is pretty much our answer. So joules equals kilograms meters squared over second squared. Now what we have is 4 joules over 4 joules over kilograms. So what we're practically saying is we have 4 joules, which is this, over kilograms. So I'm just going to substitute the J for all of this. So it's going to be, I'll just plug it in for J, kg, kilograms, meters squared over seconds squared, all divided by, so that's just this part. Now we're going to have to divide by kilograms. All divided by kilograms. What's kilograms? Well, anything divided by 1 is itself, right? So kilograms over 1. Now we're going to have to do the same thing here. We have to flip it. Just like this example. Just like the point, anything divided by 0.5, you have to flip it and multiply by the flipped. Alright, so we're going to flip it. So it's going to be kilograms meters squared or seconds squared flipped, which is kilograms. Oh, oops. Kilograms go on the bottom, so it's going to be 1, just a normal 1. Actually, let me erase that. Everything will be cleaner. Okay. It would be 1 divided by kilograms. And guess where we go? Kilograms cancel out, and we have meters squared over seconds squared. And don't forget, we have the square root. Oops, sorry. We have the square root from the 4 joules over kilograms. Always carried from here. Which the speed we're still trying to get. Oh man, I'm just confusing myself. Shit. So, right now we have the square root of 4 meters squared over seconds squared. Well, we're going to have to treat every radical, every square root for itself. So, we could say this. The square root of 4 times the square root of n squared, meters squared, over the square root of seconds squared. So, 2 times 2 equals 4, correct? Well, the square root of 4 equals 2. We're just getting rid of it. So it's going to be 2. The square root cancels out. Meters, the meters seconds, and that cancels out. So it's going to be eventually 2 meters over second. And that's our velocity for A. Yay. Ah, so messy. Oh, well, that was number 15. If you guys enjoyed it. And awesome. Yeah. Later. So, the speed would equal, I'm just going to double check. Where is it? Last one. It's going to equal 2 meters a second. The speed of A, speed of the one that has this many joules, would equal 2 meters a second. So 2 meters divided by seconds. Yeah. With a car, so we could say with a car of 1,000 kilograms. Okay, I'm gonna just redo it. With a 10,000 kilogram car moving with a kinetic energy of 2 times, well, 2 times 10 to the third is also 2,000, so 2,000 joules would have a speed of 2 meters per second. And that's how I would do it. Yeah. Alright, I hope that helped you, and this was number 15. Number 15 on the physics bracket. Alright, hope that helped. I'll see you guys next time. Husky.